Hello, and let us continue our discussion on database management systems. In the last video, we understood about ER models, but there is something which is known as extended entity relationship models. Let us understand about it in this video. But before we start, let's have a quick recap. In the last videos, we first began with components of ER model. Uh, let's start one by one. We discussed entities are any real world objects or any real world concepts. We call them as entities, right? So all the properties which describe these entities, we call them as attributes. Then all any association between two entities, we call them as relationships. Then primary key is something which is helpful to identify each entity uniquely. So these are the four components which we discussed for ER model. We also discussed how to represent them in an ER model, how to draw them. Then we discussed about types of entities like the strong entity, weak entity. Remember we discussed it with an example of loan and payment. Like in the case of loan and payment, every loan has some payment associated with it. But if the loan is not there, there is no significance of payment. Like what are you paying for if the loan is not there? So here loan is a strong entity which was existing by its own, and payment is a weak entity which depends on loan for its existence. So it is clear that there are two types of entities, strong and weak, and we discussed them both. Then we discussed about type of relationship. Now any relationship with the entities involved are strong entities. We call it as strong relationship. Then any entity a relationship where in at least one entity involved is a weak entity, we call it as weak relationship. We also discussed that strong relationship is represented by a diamond and the weak represented by a double diamond. All the notations were also very clear. So the next we discussed was degree of relationship. Like we discussed the three degrees. The first one was unary. Now unary means one, right? It is 1 degree relationship where only one entity is involved in that relationship. Like a person is friend of person, so only one entity is involved here, right? So this is what we discussed. Then binary is something where two entities are involved. A student is enrolled in course, person has vehicles, person has pets. So here in these examples, two entities are involved. So we call it as binary degree of relation, like binary relationship where we have two entities involved. But the case where three entities are involved, such as a person works at a job and works in a branch. So job, branch, and person are involved in this relationship. So where three entities are involved, we call it as ternary relationship. Then we discussed about mapping cardinality. These were the relationship constraints. Like if entities are there in relationship, they need to follow some constraint. So the constraint was of mapping cardinality, that there needs to be a fixed number which decides that from a particular set how many entities are going to be related to the other set. So this is what we call as mapping cardinality. Now we discussed about one to one, where exactly one from set A was related with exactly one from set B, and the same was vice versa. But then we discussed about one to many, where one from set A was related with many from set B, but one from set B was related with only one from set A. So example was one per student has many books, like that. Then the other one was many to one, where many from set A were related with one to set B, but from set B, one was related with many. So this was the example of many to one cardinality. Then we discussed about many to many cardinality. So where many from set A were related to many from set B. So example for that was many students are involved in many courses. A student can be involved in multiple courses, and one particular course can have multiple students. So this is what we discussed, and again we discussed about participation constraint. Remember we took the example of customer and loan. Like a customer borrows loan, so it is not necessary for all the customers to borrow loan. A customer may or may not borrow. So if a customer is involved in that relationship, it is a partial relationship because it may or may not borrow, right? But whereas in total participation, all loans need to be borrowed by one person. So all loans are getting participated in that relationship. So that is partial participation. That is for total participation. So let us move ahead and discuss about extend entity relation. Let us move ahead and discuss about extended entity relationship model. So, before we begin with extended entity relationship model, it is important to understand why we need it. And to understand why we need it, let us understand what are the limitations of ER model and where we came up with an idea that we need some extended features for it. So let's begin one by one. And the first limitation was of hierarchical representation. Now, look, consider an example where you have students in your college. Now, these students may be undergraduate students, postgraduate students, or PhD students. So, if you use entity relationship model, what you're going to do is you're going to create different entities for undergraduate, postgraduate, and PhD. But it may so happen that all students have some common attributes, right? Name, age, student ID. But these particular different types of student may have, like UG students may have some entrance exam score, then PG students may have some research topic, PhD students may have some thesis supervisor. So these are the particular topics, particular attributes for that particular case. But there are few common attributes also. Now, if you go by entity relationship model, you will end up making different entities for this all three. And what are you doing is you're storing name, age, and student ID three times for these three entities. So this is not desirable as you're storing the same thing again and again. You're wasting the space. But if you go and like write in the student's entity itself, that if the student is undergraduate, this write about entrance exam score. If the student is postgraduate, write about research topic. If you go and merge all the things, you are going to waste space in the student entity. Where if a student is PG, like postgraduate, there's no need of writing entrance exam score and thesis supervisor. So entity relationship model ends up wasting space, and it is not optimal. So what we do in case of this scenario is we create one particular entity which is student, and then student has some of its, like student can be further divided as is a PhD student, student is a PG student, and student is a UG student, like that. So this is how we represent it, and then all the common attributes are with this, like name, ID, and roll number are the common attributes which we write for student, and other specific attributes we write it for the particular entities. So this is how we represent, and this is how it is done. Now we are able to accommodate the problem. We are able to remove the redundancy, like we are not going to repeat the same information again and again. And also we are not going to waste the space for something which is not relevant. So this is the effective solution, and this is exactly done in an extended ER model. Then one more limitation, if we talk about, it is difficulty in representing real world scenarios. Now, life may not be as simple as it looks like. You cannot just simply draw a few things and that is it. You need to divide it into categories. You need to merge few things. So for that, it is not easy to represent everything in an ER model. So consider an example where student is an teacher's assistant. Now, if you're familiar with this concept that all students pursuing MTech or all that degree, they need to have a role as teacher's assistant where they do some particular extra task. So if we maintain the data of student as a teacher and teacher assistant as two different entities, we're not going to have a establish a link between them. So for that, what we do is for some student working as a teacher's assistant while being a student, it is there. So TAs have extra attributes like salary, assigned course, but not all TAs are okay. So some students work as teachers assistants while also being students. So if we keep these two as different entities, we are skipping the relationship between them, right? So TAs have some extra attributes like salary and the assigned course. They're working for the particular course. but not all students are TA, and not all TAs are regular employees, like they're not professors. So this situation is very difficult to accommodate in an ER model. What are the mistakes we can do is, if we store TA details inside student entity, we end up storing extra empty attributes for non-TA students. Like as I discussed before, if a student is not a TA, and if you are keeping a column of salary and course assigned for that student, you're just wasting that space. And if we store TA separately as an entity, we are forgetting about the connection between TA and student. So we'll discuss how we accommodate it in an ER model, but and extended ER model, but this is what makes it difficult to accommodate it in a normal basic ER model. The next limitation, if we talk about it, is data redundancy and inefficiency. Now, consider an example where a student is a member of a club. Now, if you create all the clubs as a different entities, you will end up storing the data of same student again and again in that all the clubs database, right? So, if a student can be member of multiple clubs like coding club, music club, or drama club, so each student has some common details like name, age, roll number, but club related details will may vary from one another, right? So if we store that again and again, so that's going to call redundancy, and then it is not going to be efficient. So these are the drawbacks. And so concluding, whatever we discussed in this video is basic ER model fails in real world. And extended ER model, there are some features like generalization, specialization. They can handle all these things in much more detail, and it is more efficient to use extended ER model. So the next we'll be exploring about all these concepts in depth. So that's it for the video.